Hey, all you cool cats and kittens. Okay, just kidding. It's Miss Bauer. In all seriousness, I hope that everyone is staying safe and healthy, taking care of yourselves and helping your family out. Hopefully not going too stir crazy in quarantine. I would say hopefully this keeps you entertained. Maybe yes, maybe no. I know that I'm excited to get back into some math, so let's just go ahead and jump in. So today we're going to look at graphing cubic functions. So graph the function f of x equals x to the power of 3, or x cubed, which is your cubic parent function, and analyze the domain, range, intercepts, and symmetry, and then determine what are the minimum and maximum values of the function, and it gives us an interval. So I'm just going to start by making a table first. So if I plug in -3 times -3 times -3 is going to be a negative number, and it's going to be -27. And I don't know why my Apple Pen is being weird. Sorry about that. If I plug in -2, I'm going to get -8. And if I plug in -1, I'm going to get -1. If I plug in 0, I get 0. And then 1, +1 would yield +1. +2 would yield +8. And +3 would yield +27. So the difference between this and this, the quadratic parent function, is this. I was having positive numbers, but with cubic, I can have negative numbers. So just heads up on that. So I'm going to go ahead and graph this. And the graph, as you can see, the y-axis is a little bit different. It's doubled right there. So if I plug in -3, I get -27, which is just completely off my graph. -2 would give me -8. -1 would be right there, 0, 0, 1, 1, 2, 8. Some people kind of compare it to a parabola, and then this other end is like a turned parabola, so it kind of makes that shape. So cubic, it goes pretty much up, down, up. It does this shape right there. So your domain, you can have positives and negatives. So my domain is going to be from -infinity to infinity. My range is going to be from -infinity to infinity. And sometimes you'll see that as all real numbers. My x-intercept is going to be 0, 0. My y-intercept is also going to be 0, 0. And when it says symmetry, it's not symmetrical, but it kind of is. If you took this half right here, and then I just twisted it and did that, it would match. So it's not just any type of symmetry. The catch is now we have this thing called rotational symmetry. Rotational because it rotates and it turns, and I'm using my hands to do this motion, but you can't see, but it kind of rotates that way. So rotational symmetry about the turning point. And our turning point is 0, 0. We don't have a vertex anymore. We have this phrase turning point. That is kind of like comparing the vertex and a quadratic function, but now it's just a little bit different. And our turning point is 0, 0. So we've identified all the key attributes. Now it just wants to know what are the maximum and the minimum, and it gives us the interval from -1 to 4. So that's like saying if my domain is -1 to 4. So if my domain goes from -1 would be right here to 4 over here, what's your minimum, what's your maximum? Well, I can see the minimum from the graph, because remember my point -1, -1. And if I plug in 4, 4 goes way off my graph, because 4 to the power of 3, 4 cubed, is 4 times 4, which is 16 times 4 is 64. So that tells me that my minimum is -1 and my maximum is 64. Now we're changing things up a little bit. We have 1/2 x minus 2 cubed. So if you think back, remember when it was on the inside, it was kind of the opposite of what you thought that it would be. So as you're thinking, oh, it's on the inside, which affects it x ways horizontally, it wouldn't actually go right 2, but it would go, or it wouldn't go left 2 because it's negative. It would actually go right 2, sorry. So my turning point, I'm going to call it TP. Hopefully you have toilet paper and you are not short on that. For now, just think TP, turning point. Our turning point is at 2, 0. because it slides right 2. Which means that it has rotational symmetry about 2, 0. And then this 1/2 tells me that if I make my little chart again, 1/2's on the outside, which means that all these values are going to be shrunk by 1/2. So -3, -27, -2, -8, -1, -1, 0, 0, 1, 8, 27. All of these are going to be shrunk by 1/2. So 0, 0 still stays the same. But now -8 would be -4. -27 would be, half of that would be -13.5. -1, half of that would be -1/2. Because remember, when this half on the outside, it's vertical compression. It's shrinking all of my y values. So going from my turning point, which is there, 2, 0, I'm now going to go left 1 and then down 1/2. So left 1, down 1/2 would put me right there. And then I'm also going to go left 2, down 4. So left 2, down 4. Be right there for my turning point. And then rotational symmetry just means that I can kind of copy and paste the other way. So instead of going left and down, I can go up and right, which is where that 1, 1/2 comes in. And over 2, up 4 comes in. And 13.5 is going to be kind of off my graph, so this is enough. This counts. Really bad at drawing these. Shocker, can't draw the curves. And that's my graph. So domain is still -infinity to +infinity. Range is still the same thing. So that's pretty much going to be the same for all of them. That's your constant. It's always going to be -infinity to +infinity when you have these cubic functions. Now your x-intercept is 2, 0. My y-intercept, I can see from my graph, is 0, -4. Symmetry, I already answered. It has rotational symmetry at the point 2, 0. But then how does the graph compare to the parent function? That was what we were talking about earlier. So it translates right 2. And it's vertically compressed because that 1/2 on the outside affects it vertically and then 1/2 shrinks it. And if you hear this little clacking sound, that's just my Apple Pencil against the iPad. Mine actually broke right before spring break, and I grabbed a backup one. I'm really, really glad that I did. So, last question is just, what are the maximum and minimum on the interval from -6 to 20? Which we can't really see on our graph. That's way off of our graph. So I know that -6 would be over here, to 20 would be way over here. So I know that if I can plug it in, -6 is not my minimum, but -6 is going to -6 is going to be plugged in to find our minimum, just like 20 is going to be plugged in to find our maximum. So doing that, I just need to find out, don't know what happened there, what's half of 6 minus 2, -6 minus 2 cubed. So -6 minus 2 is -8. And then -8 cubed is -512. And I'm choosing my phone calculator for this. I just typed in 8 times 8 times 8, and then I made it negative. And then half of that is going to be 256. So my minimum is -256. My bad. To do the maximum, now I'm just going to plug in 20. So now I'm going to do 20 minus 2 cubed. So parentheses first, 20 minus 2 is 18. 18 times 18 times 18 is 5,832. And then divide it by 2. I'm just splitting it in half. My maximum is going to be 2,916. So way off of the graph there. And in case you're still confused, I'm just going to do one more. So here we go. Graph this one right here. The +1 on the inside tells me that it's going to go left 1. So I know it's going to translate left 1, and then this -7 on the outside is down 7. So there's my turning point. Left 1, down 7. And if you feel like I'm going too fast, feel free to pause the video or just kind of go back and rewatch it. There's also a lot of other great videos on this on YouTube. You just need to search graphing cubic functions and a lot of them will pop up. Maybe mine will pop up. I don't know. So left 1, down 7 is your turning point. -1, -7. Now this -2, the 2, remember, makes it vertically stretched. The negative means that instead of going up and to the right, so instead of going this way, it's going to make it go that way. So it's flipped. It's reflected across the x-axis. So just going to make my chart again. So -3, -27, -2, -8, -1, -1, 0, 0, 1, 1, 2, 8, 3, 27. And I wish I could bring you all Post-its and you could write this down on the Post-its, so that'd be way easier. But now I'm going to take all of these and they're going to be multiplied by -2. So now I'm going to have +54, +16, +2, that still stays 0, -2, -16, -54. So now I'm going to go over 1 to the right, but then I'm going to go down 2. Because I'm not going this way anymore, I'm going that way. So I'm making the curve start up and go down. And then if I try to go over 2 down 16, I'm way down there. So then I'm going to go left 1 up 2, and then left 2 up 16, which is going to be on there. So it makes this shape. Remember, it doesn't go that way. The negative makes it go that way. So key features, domain and range are still every single time have been -infinity to +infinity. I had my turning point. It had rotational symmetry. About or at the point -1, -7, which is our turning point. My x-intercept I'm going to circle back to in just a second, but my y-intercept I can see is 0, -9. So to find the x-intercept, instead of plugging in 0 for x, plug in 0 for y. So it would be 0 equals -2 times x plus 1 cubed minus 7. Now you're at home. Feel free to go to Desmos and plug this into the graph and actually look at the graph and kind of go from there. Guesstimating, I think it's going to be -2.1, -2.3, -2.5. And for now, that's fine. But you can also just do it this way. And this is what we're going to get into another video, is just solving. So I would add 7 to both sides. So I have 7 equals -2 times x plus 1 cubed. Divide by -2. So 7 divided by -2 is -3.5 equals x plus 1 cubed. The opposite of a cubed is a cube root. And if I'm going too fast, like I said, go to Desmos, graph it, look at the graph, and kind of guesstimate. That's totally fine. But just finding x and y intercepts are valuable skills, and I just want to go over that quickly. So now you have whatever the cubic root of -3.5 is, equals x plus 1. To get x, just subtract 1, and that 1 would go on the outside of the radical. So it'd be -1 plus the cubic root of -3.5, and that is your x-intercept. But what would I take as an acceptable answer if you eyeballed it and you said, it looks like it's about -2 point something, and I would accept that. So now I just need to figure out what are my, how does it compare to the parent function? So how does it compare to this? Which we already kind of said. And then what are my minimum and maximum values? Nope, don't even have to do that. So how does it compare to the parent function? Translates. Left 1, down 7. Vertically stretched, because that's the 2. But the negative reflects it. So remember, reflects across the x-axis if the negative's on the outside. And that's it. That's how you graph these.